So another java.lang class, part of the java.lang package, is the math class. So this is used to perform mathematical operations. We're actually going to learn operations in the next lesson, adding, dividing, so all the simple operations. There's specific syntax for that. But for like really, maybe more difficult or more specific math operations, you're going to use the math class. So, for example, doing exponents or powers, that's going to be a great use of the math class. You actually can't do that with just regular operators. Again, we'll talk about operators in the next lesson. But yeah, math.pow has two arguments. That's going to be the base number and then the exponent. So it's going to return a to the power of b. So if I, for example, do math.pow, again, I don't have to do an import because it's part of the java.lang package, that really important one. I'm going to do math.pow. Let's do 2 to the third. So 2 to the third, it's okay if you're not a math whiz or you forgot how to do that. It's going to be 8.0. I'll let the computer do it for me, right? Now, the reason it's 8.0 and not just 8 is because if I go to the math Java doc and then I go for, um, let's see, it was math.pow. So let's check pow. Here it is. It's a double return. It returns a double, so that's why it's 8.0. A lot of exponents, right, might not fall in a perfect value, maybe, so that's why they went with double. So let's go back here. Now, I kind of totally threw the rule book out the window, right? What happened to my object declaration, right? I didn't do a, math, uh, math object equals, something. I didn't do that. So how was I able to do math.pow here? Well, that's because it's a static method. The pow method is a static method. In fact, all these methods in the math class are static methods. So the math class in Java is full of static methods, which means you don't need to create an object to use them. This is true of all static methods. Again, instance, static. We'll take a deeper dive on what that means in a future lesson. So instead of doing a object declaration, like you would usually do for like a string or any other object class really, for static methods, you actually just use the class name. Class name is math. So I do class name dot pow, and I can instantly use those methods. Static methods, they kind of are less verbose because you don't have to do the object declaration. So it's kind of for one-off method operations where you don't need to save the value or continue to use other methods on that value. Um, that's kind of one of the use cases for static methods. Again, we'll take a deeper dive on static methods later on. But let's take a look at some of these other ones. So let's do math.square root. This takes a single argument. It's just going to find the square root. Let's do of 81. That's a perfect square. So if I run it, again, it's a double return type. If I go to square root, let's see it. It's alphabetical order. Yeah, double return type. Um, so that's why it's 9.0, not just 9. Let's see. Let's do math.floor. So it's going to round down. So if I have a decimal like 5.5 and I do math.floor, oh, sorry. I forgot to do floor. It's going to round it down to 5.0, to the nearest whole number. If I do math.seal for ceiling, that's going to go up to the next nearest whole number. That's going to be 6.0. And even if I go to a smaller decimal, we usually don't round that way, but ceiling is always going to go to the next whole number. Really useful one that I used all over my code when I was doing like scientific analysis on some statistics for our like really big software system in my professional role as a full stack engineer. I use math.max and math.min a lot. So math.max is basically you're going to take two numbers, two arguments, a and b. So for example, let's take 15 and 500, and it's going to compare them, and it's going to return the bigger number. So there you go, 500. 500 is obviously bigger than 15. If I do math.min, it's going to return the smaller number of the two. The order doesn't matter. If I do 500 and then 15, it's still going to give me 15. So yeah, very useful methods there. We'll definitely be using them in the future in some of our more complex programs. So next up, so we already covered this, right? This is another example, right? To the third. Oh, we already did this one, so we don't have to worry about it. Just remember class name. So next up is going to be the random class.